Good, great. Well, good morning to everybody. My name is Greg Giroux, and I'm privileged to be able to provide support for Phase 3 on the ATD-2 project here in North Texas. I know we have a lot of folks from out of town, and you're probably just feeling really fortunate to be here experiencing our early fall weather here in North Texas. So it's only supposed to be 102, I think, on Saturday. So the leaves should start changing here pretty soon. Again, I think we have a good discussion for you today. We are about 6 weeks into our testing on Phase 3. We started July 22nd. We have 6 field facilities involved. We have American Airlines, Southwest Airlines, DFW Tower, Dallas Love Tower, DFW Tracon, and Fort Worth Center. And we have several panel members here, distinguished panel members representing those facilities that will be able to provide their perspective. So here's what we're going to do. We're going to break it down. We're going to have each member of the panel kind of introduce themselves, tell you who they represent, what they do for their particular location. And then I'm going to turn it over to Eric Chevalier. Eric, if you just raise your hand there. Eric's going to give us about a 15-minute slide presentation on Phase 3. We know there are varying degrees of understanding of exactly what we're trying to do in Phase 3, and we thought it would be relevant for Eric to kind of provide some information so when we follow that up with the panel discussion and ultimately questions from the audience, you'd have a better idea of what we're talking about. So again, welcome, and we want to make this as beneficial to you as possible. Please ask questions, raise your hand, come to a mic, submit them electronically. These are our experts here for the testing so far, and this is a good opportunity for you to get that information. So with that, I'm going to ask Joe Friend if we'll just start down the row, and we'll have each panel member introduce themselves.
Good morning. I'm Joe Friend. I'm a supervisor at DFW Control Tower for the Traffic Management Unit. Been in the FAA for 17 years. Prior to that, I did 7 years in the Navy as a controller, both in radar and tower, and that is me.
Good morning, everybody. John Short, DFW Tower, represent NATCA on the ATD project. 17 years total of air traffic control experience. 6 of that was in the military, and currently a traffic management specialist at DFW Tower.
Morning, my name's Kenny West. I've got 28 years in the FAA, 20 at Fort Worth Center as a controller, 3 at DFW Tower as a controller, 3 as a TM, and then I'm back at the center now as a TM for the last 2 or 3 years. I'm the NATCA representative for ATD-2 at Fort Worth Center.
Good morning. My name is Tim Nisnik. I'm with American Airlines. I'm not a dispatcher or ATC coordinator, but I try to pretend as much as I can. They let me on the floor. And so I spent most of my career there for the past 20 years designing, building decision support tools for our Operations Control Center, primarily in the area of disruption management and ATC and ATM.
Good morning. I'm Joshua Griffith with Southwest Airlines NOC Analytics team. So I've been with Southwest for about 8 years. I guess you could say I do kind of what Tim does, but for Southwest Airlines. And Ron and I were promised a bowl of green M&Ms today, along with a 6-pack of Coors Banquet. I still haven't seen that.
It's in the mail. It's
okay,
in the mail.
Thank you.
Good morning. Ron Newton, Chief Dispatcher for Air Traffic in the NOC. I've been with Southwest 20 years and 14 in my current position. Prior to that, I was Air Force controller, retired after 20 years in 1995, and have worked for a couple other airlines in dispatch, and now been in this position, like I said, 14 years. And thanks to Rick Dalton for putting me here. He made a mistake 14 years ago, and I'm still here. He still thinks he's my boss, but he's not. For all I know.
Hey, Ron, at least you showed up on time today. Hi, my name is Mike Sternchuk, American Airlines. I'm a aircraft dispatcher, flight dispatcher, as well as our ATC coordinator. And I've been involved with a variety of things associated with the ATD-2 and the Phase 3 operations, as well as some other things that American Airlines has been trying to do as far as fixed balancing, things of that nature. And that's pretty much it. I've been with American 35 years.
All right, very good, thank you. And Eric, if you want to come up and go through your slides.
Yeah.
Stand here. Okay.
Welcome. I'm Eric Chevalier. I've been with NASA for the past 9 years. My background is human factor and become specializing with air traffic management. And my role in ATD-2 has been I've been fortunate to help drive the concept development for phase 3 and the evaluation, and working with my partner in crime here, Greg, for the past few months now. All right. So as Greg pointed out, we want to kind of a level set, give some overview of phase 3, as this is the newer content activity on the ATD-2 side. So we've been very, as Lauren mentioned, we feel the same way. We're very fortunate to be able to collaborate with highly motivated, committed partners in the North Texas region. Thanks to Sean and Al for over 20 years of collaboration locally with the ATC and the flight operators. And it takes a village to do this, and we feel very fortunate.
He turned that so you can see it a little better.
All right, so ATD-2, you also introduced when it came about, and so one of the major decisions for ATD-2 was to, develop a prototype for TFDM and help resolve some of the surface congestion. That was back in 2014 when the team was formulating their plans. But already back then, there was a part of the deal was that in the first stage, in the third phase, we would be looking at Metroplex. And so, you can resolve some of surface congestion, but a lot of the surface congestion can be driven by demand capacity imbalance in the airspace. And that's certainly the case when you look at not one airport, but multiple airports. And so the main focus of phase 3 was to start helping some of the problems in the Metroplex environment. All right, so we looked at various TRACONs and different problems, and then it turned out that in D10 in the North Texas, there are a lot of the problems there that are common to other terminal airspace across the NAS. And what you're looking at here is the D10 airspace, 4 directions, and most of the demand the departures go to the east and west. And so what happens, when you have weather that builds, the capacity is reduced, and so the en route or terminal TMCs have to reduce the airspace, and they can't accept as many aircraft. And so typically route starts closing and there are miles in trail applied. And so the poster child in D10 is, weather sits outside of Dallas, and then you're down to one route and with 10 or 15 miles in trail. But guess what? The demand doesn't go away. So that's your demand capacity imbalance. And so the traffic can't be delayed in the air, and typically these restrictions are passed back to the towers. And so, then you start seeing some queue on the surface because these departures can't depart. And so today in the NAS, as you know, the operators can only file one flight plan. And so now all these departures are expected to fly these routes. And it's not uncommon to see 30, 45 minutes of delay on these flights, right? So that's where TOS comes in. The idea is fairly simple. In fact, nowadays in the Google Map days, all of us have looked at, we want to go to this destination, and is there a route that gets us faster there? It's the same idea, right? And so the idea is to help offload the demand where there are restrictions to help reduce the surface delay, and to look at alternative routes that could help have these flights depart earlier than they would have if they stayed on their FAL route. And particularly in the North Texas region, the north and south gates are typically underutilized. So that's the simple idea, but it's a lot harder to implement. Oops. All right, bear with me as I figure this out. So the nutshell, the overview for phase 3 was to develop a prototype, a new set of capability that leverage what has been done for phase 1 and phase 2, that leverage the scheduling capability, and expand this to the terminal boundary and include not one airport, but multiple airports. Add the TOS to this to identify when there are alternative routes that help reduce surface delay. And then also leverage existing product from the CDM, such as CDR and in the future possibly playbook routes. And eventually help move the needle forward to reduce the technology gap, the 3T technology gap. All right. And our approach has been all along crawl, walk, run. And so the main objective for this for Stormy 19, which was from May to September, the main purpose was to develop an initial set of capability, get some initial feedback, and learn from our partners, and get ready for the next fiscal year with the end goal of, as Al put it, the Super Bowl, which would be the next stormy season in 2020. So I think we did that, and we learned a lot from this summer. So what is this capability about? So let me talk to you a little bit about this. So first approach was to start simple, and we wanted to use a static TOS as opposed to airlines filing their own specific TOS. And so we realized there are CDRs out there that happen to be fully fleshed procedures from airport to airport. And in Dallas area, these CDRs happen to go through all the terminal gates, and they've been developed to actually help in the swap situation. And so we used that. And the idea was to agree on a set of routes with the flight operators and the ATC. So then the flight operators and ATC and us could use the same routes. And the advantage is those are fully standardized and updated, and so it has a lot of advantages there. Okay, next. So we extended our scheduling, our predictive engine and schedule from the surface to the terminal environment. And we fully took advantage of the EOBTs from Southwest and American. And also in the future, we'll have more and more the EOBTs from the pilots using the mobile app. And so the scheduler is basically taking into account terminal restrictions and then computes the expected takeoff time based on the restrictions that are submitted to the tower. There's more to this, but I have to give time to the panel here. So we have the routes. We have the file route, we have the schedule, we know we can compute the delay on the surface, and so now we have all the components to assess whether alternative routes have less delay than the file route. And so our system essentially keeps checking, comparing the alternative routes to the file route, and on our interface that is shared between the flight operator and ATC at the tower, at TRACON, and in the en route, the system will show to the user, hey, this flight has now at least one route that is candidate route. That means that there is enough delay savings compared to the relative trajectory cost of the alternative route. And we've taken into account the flight operator's factor to assess the cost of these alternative routes. So they are longer routes, and so it's important to be able to compare the cost. So the airborne cost is not the same as the surface cost. So it's not one-to-one. And so we've used, we have a formula for each of the operator. It's a proprietary formula. And we use that to then honor the cost from the flight operators. And then we look at our estimates of delay savings and compare that to the cost, and then say, hey, based on your input on what you wanted to know, here's are the flights with the alternative routes that would be advantageous to submit that would save you time. So the operators submit the routes for these flights, and then the ATC on their side, they can also see when these routes have been submitted, and then they can approve the route as needed. And last but not least, we have a lot of data, and we're working on developing benefit metrics and also reports that we're going to start sharing. All right, next. Just quickly, the CDRs here, there are certain destinations where the miles difference between file route and alternative route is very small, so there are sometimes cases where certain destinations have alternative route that would be beneficial to use even without terminal restriction. Next. I don't have to use this. This is magic. So a very important development in order for us to do this is to be able to know about the restrictions. And so we've worked closely with the Reroute CFW to develop standardized entries in NTML. And we develop a code to parse the data in TFM flow. And so now the advantage of this is that these restrictions are distributed across all the clients. The ATC doesn't have to make these manual entries. And so this has been a very important part of our development. And we'll talk more about this in the afternoon session. And while I mention this, I'll plug. So at 3, we have a session in a track B. And our plan is to go over this in a deeper dive, but most importantly, we'll demonstrate the system. So if you're interested to learn more about this, you're welcome to join us. Next. Okay, can you back one more? Yeah, so this is like a quick overview of the component of the capacity. So it's built upon phase 1, phase 2 STBO. So one of the main component, oh, thank you, sir. The timeline and what we've added based on phase 1, phase 2 is the estimate of takeoff time based on the terminal restriction, essentially. We've added graphs where you can compare undelayed time and scheduled time to give you a sense of the demand and the delay. We've also enhanced the map display, so now you have a very we reflect the restrictions at the terminal boundary, and here's an example of the restrictions applied, and it gives you a quick bird's eye view of the situation in terminal environment. And we've also added, obviously, traffic from all the airport. New components of the TOS table. There are TOS components that's been added to the capability. Our system is able to detect when there are routes that are available, and we'll show it to the user. We'll look at the most likely route that could be used for reroute. We also have coordination and eligibility states, which indicate whether there are routes available, and then indicate the coordination between flight operator and ATC about this submission and approval process. So we created a table that can be multiple tables that essentially represent bins where you can have the evolution of the flight reroute approval. And at the bottom, we also have for each flight, essentially the TOS. You can see the FAL route and the alternative route, and you can look at how many more miles, the estimated takeoff time, the benefits, the delay savings there. So just to give you a feel of the capability. So to go back to our field test, so we started in June with the initial capability that included some predictions and the restrictions. We went through some a certification process, and then we introduced the TOS elements. We did some training, and then we started a field test like in mid-July. So it's been about 5 weeks of tests. And so we started with specific days to test the system. We got a lot of feedback. We realized some things there that we're going to talk about. And so we did 11 days of tests, about 54 hours of testing so far. And so we wanted to start slow and crawl, and so there are many days where we didn't have any weather, so that was good, no workload. But we didn't have a lot of restrictions and flight to reroute. We still had some, though. So this is the very initial results we have for this 11 days of testing. We had about 20 routes that were submitted by flight operators. Most of the time was when there was no restrictions in place. Of those 23, 16 were actually approved by ATC, about half the time with miles in trail and some without. Part of these 16 were a procedural test to test the process of submission and approval without real intention to reroute the flight and clear the pilot on their new route. But we did that 10 times where ATC actually amended the flight plan. In 2 instances, the pilot didn't want to fly the reroute. In one case was due to maintenance, and another one to weather. But we had 8 aircraft that actually flew an alternative route. And of those very small sample, we estimate, so we compare the estimated takeoff time on the FAL route compared to when they actually took off. Very simple, right? And so we counted already almost 50 minutes of delay savings for 8 aircraft. 3 were during miles in trail, and those were the bulk of the flight with delay savings, an average of 9 minutes per flight, so almost 30 minutes of delay savings for 3 flights. And then the remainder 5 were when there was no TMI. Those were destinations that had alternative route with very small delay that showed that it was useful to reroute these flights. And so we had about 21 minutes of delay savings, 4 minutes on average. So I think this is encouraging, and it starts showing a trend that there is potential more savings during restrictions. So we've identified some benefits and needs, and I'm not going to go too much into the benefits, but we think we help make some progress with NTML entries. We've heard from operators and ATC the benefit of seeing the predicted demand to the terminal boundary, to see the restrictions, simply to be able to compare routes, and the delay on these routes seemed to be very helpful for the flight operator. And last but not least, we also leverage data to have CPDLC information from the flight plan, which also help reduce workload for the reroute, the amending the flight plan on these flights. And this may become even more useful in the future if we move towards dynamic TOS, where it might be useful to combine submitting TOS to swim and have ad hoc TOS, so that when this is in the TFMS system, these routes could be easily amended via CPDLC. So near-term needs. So almost, I think, every day we did the field test. We started by having the en route briefing what is the situation in the NAS. Very quickly, it appeared that, the playbook routes, the restrictions from the command center of restricted reroutes played a major role in the decision at Dallas for the departures. Most of the time they were, if not GDPs, they were restrictions for flights to the northeast. And so it turned out that a lot of the alternate route to the north were not available for these flights. And so we would like to provide the ability for the en route to manage and advise all their users which actual CDRs are available to be submitted. So that's our next step. But the end goal here would be that we're able to parse these NAS-wide restrictions so we can identify when the O and the TOS is impacted, Far term, we think it might be useful to exercise the 3T and swim, to have TOS being submitted to swim so that it would help ATC to then simply approve these reroute with a simple click. Modify routes, and you can see now these two work together. You could maybe, because of restrictions in the NAS, you could come with alternative routes that avoid these weather cells, and this could also be submitted and be used by ATC for approval. And lastly, we would like to also provide a little bit more leverage to the flight operators to modify the RTC, the relative trajectory cost of these TOS as needed. I think that's all I had. So I'll turn it to you, Greg. Thank you.
Thank you. Thank you very much, Eric. I hope that helped kind of level set everybody on at least what the objectives are for phase 3 and what we've done so far in the first 6 weeks. I want to turn to the panel now. Obviously, we've been testing since July 22nd with the amount of testing that Eric mentioned. But you just don't show up, and say, all right, we're going to test today. There's a lot of preparation. So I was going to ask the panel, I'd like to ask the panel, kind of give us an idea of what your preparation was to begin the testing. For the audience, we trained about 90 folks in those 6 facilities I mentioned. And I'll just maybe start with someone from the airlines to give us an idea of what took place to get us ready to be able to even enact the field test. So I'll open it up to...
I'll start.
Okay.
So what we did is we put in place both a communication strategy as well as a training strategy. We obviously had to communicate to our dispatchers what the concept was, what the purpose was, and what to expect. We also reached out to our flight department, our cockpit crew, and to let them know that this was coming. Again, high-level overview communications, but the majority of our training focused on the ATC coordinators. They were going to be the quarterback for this test from our perspective. Because of the time, the timeline that we wanted to meet, we weren't able to reach all the ATC coordinators, so we selected a core subset of ATC coordinators where we provided focused training. And that training involved classroom section where we went through the concept, the overview, some of the screens, some of the procedures, and then we followed that up with kind of a on-the-job, on-the-floor shift training, which Greg and Keenan and some of the other NASA folks came in and actually sat with the ATC coordinators during the shift, looking at the displays, real time, explaining things, and those two components kind of prepared us. And a big part of the training too was during one of the few of the initial tests, we would have participation from the NASA team on site while the test was going on to be able to provide that real-time feedback and training, answer questions, and that was really effective as well. So kind of between the 3 of those, that's kind of how we prepared. And again, very important that we used our ATC coordinators to be able to field questions because the dispatcher might have questions, flight department might have questions, and so we wanted to provide them the ability to respond to all those.
Tim, just curious that you mentioned the pilot community. What kind of communication or education took place there?
So we met with representatives from the flight department, explained what we're doing, what the pilots could expect as part of this process. Just, because they would be receiving reroutes potentially in times when they hadn't normally received those. But it was interesting because they basically said, great, we understand it. Our pilots are used to getting reroutes and stuff. We'd actually prefer that you didn't really reach out or do any big communication to them, because we'd actually like to see how they respond to this. And it turns out they actually responded almost as if it was business as usual. They just received a required reroute from ATC. They checked with dispatch, and once they got concurrence, they put it in the FMS, and away they went. So it was really more about just awareness and education, but no really in-depth or specific training.
Okay, very good. How about the folks from Southwest?
Yeah, so a big part of our preparation involved the technology aspect of this. So we are still in the infancy of our SWIM development, and so we're just about to be ready to publish and consume from TFMS. But leading up to this ATD-2 trial, we weren't ready to submit EOBT times through SWIM, and so we had to develop an EOBT model. So this started late last year. And so that's actually how my team got involved in this. My team does a lot of data science and predictive analytics around operational times. So we did model development, had to set this all up in a dev environment. Since we're not sitting through SWIM, we're publishing these out to AWS for NASA to go and consume. We're actually having to get these times back for our client terminal through a microwave dish that's on the ceiling, on the roof of our TOPS building. And so, yeah, so a lot of kind of back-end stuff there to just make this work. So once we got all that in place and started testing the communications, we started going through the SRM process internally. And we actually did find through the SRM process that the actual reroutes and that coordination wasn't materially different from what we do today for reroutes. And so there wasn't too much communication that had to be done with our pilots, but we did communicate internally within the NOC with our superintendents of dispatch and dispatchers. There was an awareness and bulletin that went out, letting them know about the trial and the new process. And so, yeah, the coordination today, we have the client terminal set up on our ATC specialist desks. So when these candidates come across, we had to have training to have them communicate with the dispatchers to make sure that we can legally and safely fly those reroutes. But again, it's really not too different from what we do. It's just actually more intelligence and data behind those decisions.
Very good, thank you. Ron, anything or Mike?
Yeah, to add on to that, we had every one of our ATC specialists were trained. Greg and Keenan were in the facility, and during all the trials, pretty much all of them, NASA was there with us to hold our hand. And we still need a little more training, and Greg's offered that. And we need to, since we only did a few tests, you kind of lose that initial training and the familiarization with the tool. We did have to go through the SMS system there at Southwest to make sure our procedures were safe. And it's really, we're doing nothing different with our dispatchers than we were before the system came online. We're coordinating what routes we want them to fly or are available to fly, and they determine which one they will fly. And we included our procedures, as he said, in our dispatch operations manual. So it's been pretty seamless for the dispatchers and pilots. We did really no coordination with the crews, because they're really not seeing anything different than they normally do on a swap day or any other day. But it's been great for us, and we're really enjoying it and look forward to keeping it going and a little more training there, Greg.
Good. Mike, anything to add?
The only thing I would say is that I think that if you go back a little ways and you look at what we would need as a foundation to set all the pieces in place, that was a key component to where we are today. And my hat's off to Eric and Al for reaching out to the folks here on the panel, the airlines that are involved in this, as well as the CDM teams that have given you guys some guidance on where we go from here forward. And so when you look at that, you know, you have an opportunity, and this is an opportunity for all of us in the NAST to say, how can we take traffic management initiatives or constraints, whether they be volume, weather related, and how can we eke out some efficiencies when we analyze those situations and try to operate better. And with that, I think what we found out was the use of a TOS is a key component going forward in the NAST for trajectory-based operations. And used to be people thought TOS was associated with CTOP, and it's not. It's a separate entity that allows us to do some things that we didn't do in the past, share those opportunities with the FAA, and then produce some better results as a result.
Okay, thank you. And for the FAA facilities, obviously they'll have them comment. Just to level set it again, they, at the 3 facilities we have represented today, they've had the ATD-2 equipment for quite some time. And of course, the phase 3 portion is different for them. So I'll turn it over to them if they want to just give us a little brief overview of what their training was like and what that looks like. So
I'll speak for DFW Tower and the TRACON as well. So we have a team of, John and I are part of a team of 6 traffic management coordinators that run DFW. We basically quarterback DFW Tower's operation every morning and evening shift. We've had this equipment in place, I believe, since 2012, 2013. We've had it in place for quite a while. The new TOS system was new to us. So we use this equipment prior to TOS as a #1 decision tool on how we're going to depart DFW, what departs what side of the airport, how we segregate the traffic to east or west side to try to optimize how the departures work out. And I don't want to jump ahead if there's a question about that later, but our training process for TOS was the NASA folks invited us over to their facility at North Texas over at the Fort Worth Center. We visited with them there. They showed us some slides and explained to us how the TOS system is going to work. Then in addition to that, they came to the facility and they shadowed our operation as well in the tower with us side by side at our traffic management unit during these tests to kind of help us walk us through the understanding of how it's supposed to work. So it's pretty easy. Same for the TRACON. I was in the TRACON the last 3 years as well. So at the TRACON, it's a little, it's less involved down there because it's mostly between us en route folks and the tower folks. But at the TRACON, we also did receive training there as well for the 6 traffic management coordinators and supervisor down there as well. But like I said, for them, it's pretty easy. It's kind of running in the background, if you will.
Kenny, anything?
Sure. Fort Worth Center, what we had to do there was we had to develop some new NTML entries, and Mike Spurgeon was a big part of that. He's not here. We developed those new entries. We had to train all the TMs on the new entries, how they worked. They have to have a time associated with them now, which is different than we did before, so it's a little bit more labor intensive for us, but I think it's worth it overall. We went over the equipment, which has been there probably about as long as it's been in the tower, and I used it quite often over there. Obviously, just like they said, coming to the center, it's just something that was there and would be observed but not really used. I've tried to educate a few folks on how we can use that better to our advantage there. Pretty much what we did is train the trainer, and then we sat down with individual TMs and would show them the functions, how it worked, and how they could interact with it better. That's pretty much how it worked for us.
Okay. Anybody else?
Leveraging the swap routes that we already had just made it a seamless transition. It's something that we did in the past, but we were just automating the procedure using this TOS in phase 3. So it was it's nice to have that graph that was shown earlier, how much information can be displayed in just one graph, and making that process automatic for us now to prove that, you know, things are working, that in our head that we would take an aircraft that would normally be going east because of demand, we would reroute them north, but now the system's doing that automatically for us. But the unintended consequences of this are delay savings of aircraft that you won't see that were rerouted. So it's another benefit for the phase 3 that is not being really utilized right now. But our airspace is really efficient. I think we're really seeing that at DFW, of having the minimum amount of TOS availability at DFW.
Right. Okay. was going to cover one question real quick, and then we'll go to another one for the panel. Someone asked, how are departures from adjacent airports other than Dallas Love and DFW being handled? And right now, during this test, they are not factored into the equation. However, we, our software folks and others, programmers, are working on what's called a small airport model that will incorporate those aircraft into the system, not into the system to the point that they could submit a toss, but that they would be factored in and from a capacity, efficiency, and delay standpoint. So that is coming. Let's see, we touched on this just a little bit, but maybe a little bit more. And again, I'll start with the airlines. If you could describe where the ATD-2 equipment is located in your operation, why you chose that particular location. And I know you both said the ATC coordinator uses it, but maybe just a little more, on why there, why not in the dispatch unit, why not somewhere else? So,
Yeah, on the American side, so our ATC positions are very similar to what they have at the command center. We have broken down by en route, strategic, and terminal specialists. So we've got it right near the DFW terminal specialists, and it's co-located also at our en route position, which gives us that situational awareness on departure routes that might be impacted with weather or some type of constraint. So that's just how we've designed it, and works pretty well because it's within earshot of all the other folks, and we get that OJT part of the equation that backs up the classroom type training that we've had too.
okay.
And just to tag on one thing, because you have a lot of candidates come up, rather than push all those directly to the dispatcher and having them to do a lot of extra work, we've moved some of that upstream to the ATC coordinator who can vet some of these candidates prior to them going to the dispatcher. And so specifically, they're looking at things like fuel feasibility. Do I have the fuel from the filed route to handle the TOS route? If I don't, is the time and savings enough to warrant potentially refueling? Is it weather feasible? Because some of these TOS routes may go through weather, and so you want to do a quick display of that. And so what they would do is they'd take the candidate, they'd take the filed route, display them both on our kind of in-house weather tool, kind of see where the routes went to make sure that they can do some preliminary vetting before they, again, send them to the dispatcher. And also looking at things like mission feasibility. Perhaps some of these filed routes were there because they had to comply with, an overwater restriction or some other MEL that the TOS route may not be satisfying. So doing a lot of those things up front made the dispatcher receiving them a lot more intuitive, effective. They were able to process them more efficiently.
Very good, thank you. I think I have this question 3 times, so we might as well get it over with. Can Mike Sternchuk submit questions from his flip phone? So Mike, if you just want to hold it up real quick, and we'll work our way through that.
Well, I'll just say that if Ernie would give me the app, I probably could.
Very good. Another question we have, and I'll start with Eric maybe on this one. It's how important are EOBT times to the system and the process of projecting what the surface delay is going to be?
Yeah, I'd say it's fundamental. With the OBTs, we get better accurate demand to the runway, and we take that all the way to the terminal boundary. With the OBTs, we're able to come up with, estimated sequence and takeoff time at the runway, and that's what we use essentially to compute delay savings. And so we'll use the OBT not only for the FAL route, but also for all the alternative routes. So without the OBT, I think our predictions would be, less good, certainly.
Okay, very good. Let's see, Tim touched on this a little bit, but I'll go back to our airline folks here again. When Eric showed us on the table when a flight presents itself as a candidate to take a reroute. Can you just walk us through what is the ATC coordinator looking at before, obviously when a flight shows up as a candidate, it's not automatically submitted. It's alerting our airline partners that based on their own criteria, this flight may be a good candidate to submit to ATC. But before you do that, what's the coordinator looking at before they make that sort of decision? What are they factoring in?
All the routes that coming through, the ATC specialist is vetting those before we go to the dispatcher, as Tim said, to see if they're even viable. And some of the CDR routes, because they're CDRs, they'll show as a candidate if the whatever gate's open, but beyond that gate, because CDRs are city pair, that route is not a viable route, even though it gets us out of the terminal fine. But if we file that route through a thunderstorm another 100 miles outside that gate, we can't use that. So the ATC specialist presents the most viable and the best route that's available as a candidate or as a prospective candidate. And we'll coordinate that with the dispatcher, and they'll select that route. And once they decide which route they want to use, we will submit it through the equipment provided there.
Okay, very good.
You know, in addition to, like I mentioned, making sure the route, the alternative route is weather feasible and fuel feasible, one of the things that we noticed that we had a high level of engagement from our dispatchers, and they were starting to question some of these candidates. And so specifically because when the system would look at the route comparison, it would look at track mile differences. But our dispatchers look at wind miles. And so there may be a fuel burn difference that is not necessarily consistent with the savings. And so it was an indication that our dispatchers were very engaged. And so what we had some of our given, if time permits, our ATC coordinators would also do kind of a fuel burn assessment to look at that. So even though the track miles may indicate that there's a benefit, we actually need to look at the wind miles to see if the fuel burn still justifies that. And so that's an area of opportunity. The other thing is we needed to make sure that the alternative routes that were submitted as candidates weren't subject to other TMI restrictions, like involved in a ground delay program with an EDCT, or subject to a playbook route that would also preclude us from accepting that. So a lot of those upfront kind of vetting made what ultimately got to the dispatcher more viable.
Okay, very good. Anybody else from the airline side from that? Okay, go ahead, Eric.
Can I ask if you could describe the time horizon when you make the decision for submitting reroute?
Yeah, I think that's actually one of our takeaways as something we've identified as a lesson that we need to figure out. So there's certainly, if you make a decision too early, those restrictions might change. Then too late, you limit the amount of time that you can coordinate that decision. So we're still trying to figure out what that Goldilocks kind of time window is. But I think typically once it's been around maybe 20 or 30 minutes out. So yeah, we're still trying to evaluate that based off of the candidates that we're seeing and what we're submitting. But yeah, we think about 20, 30 minutes out might be the sweet spot.
Okay.
And I would agree with that. And one of the reasons for that is that that's when probably that EOBT value that you mentioned earlier becomes more accurate. Right. And the more accurate you can have that, minutes matter in this, because when you're looking at the timeline and the sequence, 5 minutes off could mean a considerable difference in the sequence, which the whole calculation then becomes affected by that. So in order to have more consistent and stable computations and estimates of delay savings, we want accurate as much information. So, but we also want to provide enough time for the dispatcher to go through their process and the pilot to be able to put that in the FMS and do that coordination as well. So about the same time frame as we're seeing.
So I think it's probably fair to say at this point we're all still trying to, figure out exactly what that parameter, the best parameter is, and I guess that's what testing is all about as well. So this hopefully follows a question that we have also about the process. So the airline folks have described, they see a candidate presented on what we call the toss table that Eric showed you earlier. They go through their process of evaluating weather, fuel, and all those things, and now they do submit the reroute to ATC. I'm going to ask our tower folks, what do you do then in terms of what takes place within the tower?
We are looking at the same table that the airlines are looking at. So once they submit a candidate, we see that it's available for a reroute. We take a look at what's going on in the operation at the time. So we have to make the decision Can we reroute this aircraft? Is the aircraft in the way of other airplanes? And then once we make that decision, hopefully prior to 20 minutes out is a better time because the aircraft more than likely has not taxied out yet. So we don't want to be rerouting aircraft that are sitting at the runway, blocking other airplanes. So I don't know if that answers the question exactly.
It does. So John and Joe, in the tower perspective, you see it submitted and then you approve it. Can you kind of walk us through what coordination takes place from that point? Because now you've just approved it in ATD-2, but more has to take place right before the pilot actually gets the reroute. So if you wouldn't mind.
So I would, once that route is approved, I would have to go to the controller working the flight data position to reroute that aircraft or call for or center, have them reroute that aircraft on that appropriate route that the system recommended. And then the aircraft would then have to go back, get a new clearance via voice or CPDLC or DCL. Our preference would be Datacom. But it just makes it a seamless transition because you're already adding more complexity to the situation with voice by having to that aircraft again. So it's basically a swap situation, not as many airplanes though. So once that aircraft receives that reroute, then the system picks that up and says, hey, it's been approved, everything's good to go, and we wait on the pilot to get the numbers and taxi out on the new route.
So is it fair to say, John and Joe, really it's a similar process to what you've always used for a reroute? You're just receiving that request through the ATD-2 process in a little different way, or it's presented to you in a different way, I guess.
Yeah, that's correct. And kind of the advantage to it, too, is that the airline generally is not going to submit something that they're not fueled for or that they have not planned for. That's the advantage of this versus what we do on a regular basis, where we have weather moving through the DFW area, and we see an advantage to rerouting aircraft that the airlines haven't caught on to yet because we know kind of what's going to happen and what our plan is 30 minutes, 45 minutes from now. So we start rerouting planes a lot of times on our own to do that, and we end up 10% of the time with planes that don't have the fuel for that. Right. So we have to do an alternate plan, something like that. Right. So the advantage with TOS is they're not going to submit something that ultimately they can't fly. Right. So and it's done prior to them leaving the gate. Most of our stuff's done once they leave the gate.
Okay. And that probably would take us back to something that Lauren mentioned earlier about the reduced coordination. So now instead of asking the pilot and then them calling the dispatcher and things like that to arrange, if you will, a reroute, because it looks like a good option, it's actually the airline submitting it. And as Joe said, they're not going to submit something that they're not ready to do. So that's one of the goals of this process, obviously, is to reduce that coordination as well.
Yeah, I would say previously that's what we would have to pick up the phone. If we knew that an airplane would benefit to just say go on a north route, I would have to call the ATC coordinator to see if they can even take that route and then go back and forth and wait. Now the system's doing it automatically for us.
Hey, John, quick question on the on your side of the equation. I know we've had some behind-the-scenes communication with Eric and Al regarding the leveraging of the PDR tool. Are you using that yet, or any of the tosses within that yet, where you can issue the reroute via that?
The tower does not have access to the PDR, so that's a center-only tool at this time.
Right. Coming hopefully to a tower near us soon, but I don't know the exact dates.
We've asked for it.
Yeah, we may have some folks in the audience that. So I hope that answered the question about kind of walking our way through the process. I think I can't remember if it was John or Joe or maybe both, emphasizing that the process is expedited with CPDLC aircraft, and I think that's true from both the ATC perspective and from the cockpit perspective because of the reduced complexity. So let's talk about benefits so far. I know we're early, as Eric described, 5 to 6 weeks. But if you just break it down maybe into what have you seen beneficial so far, maybe into, some of it is situational awareness, I think, because you're seeing things that you didn't have access to before, and or maybe, more direct delay type benefit. So I'm just curious so far, what thoughts from our folks that you've seen?
Yeah, we're not seeing a lot because we're not doing it a lot. You know,
Right.
we're still well into the crawl stage. We're not, haven't done a lot, but the reroutes that we have done have been a savings. We've done a few actual that we would, not on a weather day, but we would take an east and move it up north without a lot of fuel burn, but the savings that creates behind them, it takes him out and frees up another spot for that eastbound departure or westbound departure, whichever way you're going. So it's all cumulative. You get the one airplane off and everybody else moves up as well. So we're seeing that in the time savings. And the biggest thing, as you mentioned, was situational awareness for our guys. They're sitting there, they can see these candidates, whether we're in the toss is turned on or not. They can see the routes available, and we can start coordinating with the dispatchers without being in a trial. And we'll call ATC and reroute them ourselves. We see advantages to that. That's probably the biggest thing right now is just the situational awareness and us being available to take advantage of those scenarios that we see where we could save some time on a different departure gate.
Thanks.
You know, on the situational awareness side, even just the display, you showed on one of the sides the fixes, and being able to see that fix status immediately, almost instantaneously, when those fixes get compressed or closed or a mile and trail gets added, we see that, and we see it visually, and it's a very effective way to communicate that information in a time-sensitive manner, and that's been one of the really benefits from this, is that they've seen a lot of value in that. The other thing that we've seen also is in the value of the timeline, giving our folks access to that timeline, and to even see the kind of the taxi out or the delay computations associated with where you are in the lineup, and then seeing the balancing of the various runways helps us to just have an awareness that we never had before. And I've even observed a couple times where we'd have dispatchers come to our ATC coordinators inquiring about a specific flight, and them being able to actually go to where that flight is on the timeline and give them a much more accurate assessment of when do you think I'm going to be off, whether it be a crew issue, a critical passenger connection issue. That level of information is something that they've never had access to, kind of at their fingertips without having to dig into it or do a lot of that. So just in addition to just the actual reroutes and the savings there, that information that's constantly being updated, refreshed, and displayed real time is very valuable.
Okay, very good. Tim? Go ahead.
Interesting
Go
at
ahead,
Fort
please.
Worth Center, what Tim was saying, the situational awareness with the display, showing the routes open and closed, and the mile and trail has actually helped the TMs in the area. We actually have a new display coming in, hopefully within the next week or so, which will be, we use the ESIS display now, if you're familiar with that, and it can get cumbersome reading this route's closed, it's got tenant trail, and you got 5 or 6 or 7 different things you're looking at that you have to read and figure out where they are, as opposed to now there's going to be a visual clue with the grayed out areas and the miles and trail added to those. So that'll be a great benefit for the TMs, and we should be able to, in the heat of battle, keep up with what's going on a little better.
And Kenny, while you have the mic, one of the questions is what coordination is being done with adjacent ATC facilities? So I'll take that to mean adjacent centers, that the reroutes may take place or that they could be in effect.
There's really not much that happens right now. It's it's pretty seamless on the ATC side. It doesn't matter if the guy goes north or it goes east or west. We don't really seem to worry about that too much. In a swap situation, when everybody's going a new direction, or that there's a lot more coordination involved with that. But we're talking just a few flights a day. I don't know how many the number is, but it's not really that big of an issue for us. It's, as far as the controllers, it's pretty seamless for the controllers. TMs, seamless for us pretty much too.
Very good, thank you. We had a question also, are other non-American and non-Southwest flights able to benefit from the reroute options, or is the test only for American and Southwest flights? So Eric, please.
Yeah, I think Ron already pointed out, when you offload demand, so when you have restrictions, I'll take the example at DFW, you have 10 miles in trail, every flight is spaced by 2 minutes, and so, when you're at the end of the queue, you may have, 40 minutes of delay, and so imagine now you take some flights away, and they can depart north and south in between those east departures that are spaced out. So not only the flight that is rerouted has some delay savings, but all the subsequent flights behind that flight also save some time. So we're seeing some community benefit. There's the direct benefit for the flight and an indirect benefit for everyone. And it's not just one airport, it's 2 airports. So if now, the flights at, American flights are rerouted, it will also help Southwest flights depart earlier. So there's definitely some benefits there.
Okay. Another question we have is, are the delay savings only departure delay or overall arrival time delay? So,
Yeah, so in our concept, we're not controlling the arrival time at the destination. I mean, indirectly, we're influencing it. But as you can see, our scope, our trade space, is the surface operation, and we are only comparing surface delay for departures by comparing routes to get out of the terminal environment. So we are only influencing the arrival time by proposing earlier takeoff time.
and the one thing I would add to that also, Eric described the delay savings numbers. He showed the slide earlier. Right now, that reflects only the direct savings for that individual flight, what the takeoff time would have been on the original filed route versus the CDR route if the candidate is presented and approved. So it's not reflecting the delay savings for the subsequent departures that basically move up in the slot. That's something we've talked about, and I think we know it's there, but I think it's fair to say we're still trying to figure out how to capture it at this point. Yes. Oh yeah. Go ahead, Joe.
Are we consistent with our philosophy? Like in the Northeast, we're going down this path of the IDRP, the Integrated Departure Route process, where I thought the airlines were submitting TOSs that would be accepted. Therefore, the FAA automation, the TRACON would then just pick ATD-2. Whereas you've taken this on the other side and said, okay, here's all the stuff. And after 20 minutes before, there's a process using your tools. I'm not sure that's consistent. I'm not sure, is that what you have here doable in the Northeast?
The question ultimately, thank you, Joe, was is this process doable in the Northeast? Where's Ralph Tambur? No, I would say, yeah, I would say it's hard. Yeah, it's hard to say. I think at this point, I don't know if Carol's here today, but I did like her, statement of one airport is one airport. I do think that maybe one of the differences, if I understood your question correctly, is this is probably a little more tactical than looking out to, an hour and a half ahead, because, and maybe this could be a difference in the weather. And again, I'll open it up to these folks too, but the weather appears to change pretty rapidly here, and maybe it does that in the Northeast too. But I think the idea was try to capture some of those changes and not submit that so far out ahead that yes, you get it approved, but now the route you're flying is a route that you don't really need to fly the additional miles because the original route is available from a weather standpoint. I don't know. Let me see, airline folks, anything to?
Yeah, I'll just mention that I think the two go hand in hand because you're going to be submitting trajectory option sets, and their software will still be able to analyze them based upon your relative trajectory cost. And so the FAA may use them in a slightly different manner in that, hey, coach closed off, what's your next best toss in there, and how can I get you out of town? So I do believe they go hand in hand. I don't know, Tim, don't you kind of see it that way also?
Mm-hmm. Yeah, I think part of it is to the fact that this is using static tosses instead of dynamic tosses. So something in Northeast I think really requires dynamic tosses, and the capabilities just aren't there yet on a lot of the airlines. And so this is really a way to leverage that concept, but a little bit more in the static. And rather than us push toss, we're actually being the other direction. We're being presented opportunities. and presented opportunities that are a little bit, like Greg said, a little more tactical, when a lot of the uncertainty is resolving itself, to know that we're really seeing, that we have confidence in that we could actually get savings. But I think that's a big part of it, is the dynamic versus static nature of the tosses.
Eric, go ahead.
Yeah, I'll add something. You mentioned IDRP. So as you know, IDRP has this algorithm to predict the weather impact on routes. And conceptually, I think it would be a nice, addition to this concept. And I don't see any conflict between IDRP and this prototype. I think it would be awesome to add this prediction of weather impact, and that would look at the available routes that Tim just mentioned, and it would only help, leverage CDRs, and yeah.
Okay. Another question we have is, several people asked us, why weren't CDR and playbook routes used more frequently before? So, John, I thought you had a response to that. No.
I mean, we did use the CDRs, and we don't use playbooks out of the Metroplex a whole lot, but we take advantage of the swap routes, and that's just basically what this program is doing in phase 3. It just gives the controller the ability to see exactly what airplane benefits from it, instead of using a best guess, basically, for us. So we're using the swap routes as we would in a swap event.
And I think from an airline perspective, it's a completely different scenario. A lot of the CDRs and playbooks are really weather avoidance options. We're talking more here about an efficiency use case. And so the two, we would never historically have gone to request a CDR, because that's been primarily a weather avoidance option. So we're kind of using them in a slightly different fashion. And in fact, that's an opportunity for improvement here too. Right. Because since a lot of the CDRs are built around weather avoidance routes, there's maybe an option to create more efficient CDRs that are more focused on this particular use case. And even in the playbook options, again, a lot of the playbooks are weather avoidance. Maybe there's options to give flexibility to the playbooks that allow us to make use of different departure fixes and then join the playbook routes later on to accomplish whatever en route constraint or structure that they're trying to achieve. So this is kind of a different mindset to say the same concepts can apply, but maybe we need to tweak some of the inputs, and that would actually create more viable candidates, I think, as well.
Right.
Well, I think what ATD has brought is the surface piece to the table to show what surface demand is at the airport and how to use these routes in a better fashion.
And maybe, go ahead, Eric, go ahead.
Yeah, I'll add, I think one of the last test days, there was a north route that was not available, and the CDR was just cutting the corner of a weather area, and there was a playbook in place there. And I was thinking, oh gosh, if we could just tweak that CDR, it could be used. Yeah.
Right. But we have one wrap-up discussion or question here, but and I appreciate Joe standing up and asking a question. Do we have anybody else that maybe hasn't submitted one electronically that also has a question out there before we? No? All right, one last question. And this, whoops, did we miss somebody? I'm sorry.
Straight back.
Okay. Wow. I'm too old to do that, Eric. I just want you to know.
Yeah, that was great. So quick question. So we were talking about this is the FY19 process. So when is this actual phase going to conclude to move into your next step?
So good question, Sandy. I don't think we actually know. We're still testing. We are going to get together as a community, user community in the fairly near future and talk about, even though we've done that regularly with telcons, but a little more introspective meeting and talk about where do we go, where are we, what do we do between now and next year. We are actually already planning for next year because of, and we're not going to be able to get to it today, because of lack of time, but we've learned a tremendous amount through 5-6 weeks of testing of enhancements to the tools that need to be made. I would say probably the first and foremost one is, and Eric covered it briefly, but something to screen out routes that really aren't available that right now show up as candidates, but because of playbooks or weather or things like that, they really aren't routes that an airline would be able to choose or that ATC would be able to authorize. So, and then we hope to be, actually walking and running when we get to what we're calling Stormy 20. So, let's see, I'm looking.
I'm willing to run again. Give me the opportunity.
So I don't see anybody. One last question to the panel. How do you feel that this type of product fits into the future of the NAS, into CDM concepts, and how does it relate to other areas of your operation? I'll just open that up to the entire panel. Go ahead, Mike.
Well, I'll just say that, I kind of mentioned it earlier that, it's that life cycle of a flight from out to off to en route to on and in. And I think when you look at that and you look at trajectory-based operations, tosses are a part of the future. And we both have to learn to live with that and how we communicate those tosses and preferences to make a more efficient NAS. There's many things out there just on the en route side of the equation where a TMI is canceled, and now how do we leverage airborne reroute and PDRR within the tools that NASA's working on and blend them together to make that seamless efficiency go through the life cycle of that flight.
Okay, very good. Anybody else?
Yeah, in the center operation, I referenced that display that we're going to have hopefully here soon. There's a benefit that we didn't see originally, but we do now, is the corners and the arrivals. We can also display whether they're closed or there's miles and trail put on those corners also, which will help the TMs make better decisions and just be better for our operation. We didn't see that coming.
Very good. Anybody else? Tim?
Yeah, I think in addition to the TOS, the idea of common situation awareness around real-time awareness of restrictions, demand, and capacity is right in the CDM concept arena. But the other thing is just the collaboration is also, key to this. The collaboration between the airline operators and ATC, the tower, the center, and the TRACON, that's really where you see the value. Because, it does take the whole process and all the pieces, all the people to play their roles for you to actually see the results. And that's been very good, too. And just the ability to see real time the assessment of doing nothing versus doing something as an alternative. So seeing the calculations real time, too, accurate calculations about estimated time of delay or estimated benefits from taking an alternative action, that's key to, I think, future CDM concepts as well.
Okay, very good. And I think we'll end on that. I want to thank the panel personally for such a great discussion, just a tremendous amount of experience and expertise. So thank you all very much, and thank you. So.